Alright, thank you so much for joining us today. In this video, I have 49 questions that I want us to go through together towards the final exams preparation. So let's jump right in. So this one, they've given us f of x and we want to find the second derivative and set it to 0. So let's just go. So f of x is equal to 5 on 2 x squared minus this. So let's take the first derivative. We are going to have 5 times 2x minus ex. So this will cancel this and we are going to have 5x minus ex. That is f prime. We want the second derivative, so let's go again. F prime is equal to 5 minus ex. So we want to make sure that the second derivative is equal to 0. So this is going to give us 5 minus ex, which is equal to 0. Then let's find for x. So ex is equal to 5. For us to find x, we need to pick the natural log on both sides. So we are going to have this, and this is going to give us x is equal to ln of 5. So basically, this is what we are going to get for the first one. Wow. Now let's look at question 2. Let's look at question 2. So question 2, we want to take derivative of this function. So let's use the change rule to do that. So we have f of x, which is equal to 1 plus x minus 1 over x, 5 over 3. So let's apply the change rule. So f prime will be equal to, so first we need to apply the power rule. So 5 on 3 will drop down. We maintain the 1 in the parentheses. Then we are going to have 5 on 3 minus 1 times, now we differentiate what is inside the parentheses, 4 minus x to the power minus 1. So now let's try and finish it up. So this is going to be 5 on 3, 1 plus x to the power 4 minus 1 over x. Then 5 on 3 minus 1 is the same as 2 on 3 times, and when I differentiate 1, I'll get 0. But when I differentiate this, I'm going to have 4x to the power 3 minus, when I differentiate this, minus 1 will drop down, so I'm going to have it to be plus. Then x to the power minus 1 is going to be minus 2. So let's see if we have something like that there. Okay, so we can do the last simplification and we will see the final answer there. 1 plus x to the power 4 minus 1 over x. 2 on 3, then this is 4x to the power 3 plus 1 over x squared. So I think the answer is supposed to be C. Yes, it's here. So good. So that's it for question 2. Let's look at question 3. Let's look at question 3. What is the equation of the tangent line to the curve sine x plus cos y equal to 1 at the point pi on 2, pi on 2? So first we know that equation of the tangent to the curve, this question is talking about a curve. So equation of the tangent will be this. So don't forget the difference. I think we did one under circle and we said equation of the tangent is to the circle is minus 1 divided by the gradient, because that one is to circle. So pay attention to whether they are talking about curve or a circle, because for a curve we are going to just have a tangent line, but for a circle we are going to have it perpendicular to the radius here and then the circle too as well. So pay attention to that. So here we have the point already here. So we are going to have y minus pi on 2 x minus pi on 2. So what we just need is we just need the gradient, right? We just need the gradient. So let's find the gradient using this equation given to us here. So what's the equation? Sine x plus cos y is equal to 1. Is that right? Yes. So let's use implicit differentiation. So when I differentiate sine x with respect to x, I'm going to have cos s. When I differentiate cos s, I'm going to have minus sine x. But remember, this is y and we are dealing with implicit, so I multiply it by dy over dx, which is equal to 0. So this is going to give us sine y dy over dx, which is equal to cos x. So I move this one to this side, become positive. Divide through by sine y, and I'm going to have dy over dx. Sorry, yes, dy over dx is equal to cos s divided by sine y. We have a point, pi on 2, pi on 2. So let's just put it in and see what we are going to get. So we are going to have dy over dx is equal to cos pi on 2 divided by sine pi on 2. Cos pi on 2 is 0, sine pi on 2 is 1, so the slope is going to be 0. So since the slope is 0, I'm going to have this over 2, which is equal to 0, and this implies that y is equal to pi on 2. So we are going to have this one to be b. So they are pretty much straightforward. Now we want to find this. No, we want to find big F prime of 5, given that this is equal to that. So this is what we want to find. We want to find F prime of 5. But for us to find big F prime of 5, we need to differentiate this one first. So we have big F of x, which is equal to small f of gen of x. So let's use a change rule to differentiate f prime of x. This is going to be f prime gen of x times gen prime. So this is the change rule, right? Now let us plug in the 5. So we are going to have big F of 5, which is equal to f prime of gen of 5 times gen prime of 5. So now what is gen prime of 5? That is 6, right? And then what is gen of 5? That is minus 2. So let's do that. So this is f prime, gen of 5 is minus 2, and then gen prime of 5 is 6. Now what is f prime of minus 2? That is 4. So we are going to have this one to be 4 times 6, and I believe this one's supposed to be 24. So we are going to get 24 for this one, which is D. So pretty much straightforward. Now let's look at question 5. Question 5, we want to find the horizontal tangent, right? Now basically when we talk about tangent, we want to see it's with a curve, right? So it means that that's where the f prime is equal to 0. That's the tangent. So basically we are thinking of the slope, right? So now since we have f of x to be equal to 1 divided by 3, x to the power 3 minus x squared plus 3, then we just need to take the first derivative. 1 over 3 times 3x squared minus 2x. And when I differentiate this, I get 0. So I'm going to have x squared minus 2x. So since we want to get the slope, we are going to set it to be 0. So x squared minus 2x is equal to 0. X out, x minus 2 is equal to 0. S is equal to 0. X minus 2 is also equal to 0. And s is equal to 2. Sorry. So you are going to have 0 and 2 for the tangent. Wow. Wow. We are preparing ourselves for the exams. So now let's look at question 6. Let's look at question 6. So question 6, we want to check if f is concave, right? So let's see where the function is concave, either up or down, right? So for concavity, we need to take the second derivative, right? So given f of x, which is x to the power 3 minus 4x squared plus 5x, f prime of x is 3x squared minus 8x plus 5, and then f prime of x will be equal to 6x minus 8. So now this is what we are going to do. Now let's find for x. So 6x minus 8 is equal to 0. 6x is equal to 8. Divide through by 6, 8 over 6, and this is the same as, I think, 4 on 3. Good. So for us to check concavity, what we are going to do is we are going to place this one on the line here. And concavity is when the sign changes, right? So if the sign changes, then we can call this one point of inflection. So we are going to put this one inside the second derivative, not this one, anything below and above inside the second derivative, which is this. So second derivative was equal to 6x minus 8. So let's pick something here. So remember, this is 4 over 3. So this is kind of like 1 point something. So I can plug in 0 here, right? So when I pick something like 0, plug in 0 here, and this is going to be minus. So this is going to be decreasing because this is minus. Pick anything here, let me say 2, and plug it in. When I plug in 2 here, I'm going to have it to be positive. So this is going to be increasing. But what's the question asking us? The question is asking us to find the open intervals where f is concave. Okay. So the question is supposed to be modify it small, whether concave up or down. Because this one is going to be negative infinity and 4 on 3. This one is concave, this one is concave up, and this one is concave down. So find the open interval where f is concave. Oh, okay. So f prime prime is less than 0. Okay, so less than 0 means that concave up. Good. So concave up will be here. Less than 0 is this side. So we are going to have this one, not this side. Good. So I think that's where we're supposed to pay attention to. So this is going to give us C. Okay. So don't forget, if f prime prime is less than 0, we are talking about concave up, which is right here. Good. So that's what we have there. Okay, that's for question 6. Let's look at question 7. We want to find k prime of x, given that k of x is equal to the ln of x and then x squared. So let's use the quotient rule, u ven, right? So u is equal to this. U prime will be equal to 1 divided by x, and then ven is equal to x squared, and then ven prime will be equal to 2s. So let's use the quotient rule. We see that k prime of x will be equal to ven u prime minus u ven prime divided by ven squared. So this is going to give us ven is x squared, u prime is 1 over x, 1 over s, minus ln of s times 2s divided by this all squared. So let's see what we are going to get. 1 of the x will cancel. So I'm going to have s minus, this is going to be 2s ln of s divided by x to the power 4. I can factor 1 of the s out, yes, and have 1 minus 2 natural log of x divided by x to the power 4. When I cancel one of them out, I'm going to have 1 minus 2s divided by x to the power 3. So let's see if we have something like that there. Okay, so I think, and we can also write this one as 1 divided by x to the power 3 minus 2 natural log of x divided by x to the power 3. So I think the answer is supposed to be C. Is it C or D? Is it minus or plus? Okay, it's minus. So it's going to be this right here. If f of x is equal to this, then the set of x for which this exists is, okay, so this one is basically talking about the domain. We want to ignore all the values. That's going to make sure that this function does not exist. So we just pick the denominator and set it to 0. So this is equal to 0, and x minus 1 is equal to, x is equal to 1, yes. So that is the idea. So it means that when x is equal to 1, the function will be undefined. So we are going to take all real numbers except x is equal to 1. So the answer is going to be D. Now let's look at question 9. Question 9, we want to find the, given that f of x is equal to x to the power 4 minus 4x squared. We want to find the derivative 4 times. So first one, 4x cubed, using the power rule minus 8x. F prime prime is going to be 12x squared minus 8. F prime 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 is going to be 24x, and then the last one is going to give us 24. So C. Let's look at this one too. We want to take derivative of this composite function. So we want to differentiate f of gen of x. So we've done something similar. So this is the same as f prime of gen of x times gen prime of this. So gen of x is given, which is equal to square root of x, which is the same as x to the power 1 over 2. So we need gen prime. So let's use the power rule to apply to this. So this is going to be 1 divided by 2x minus 1 over 2 minus 1. 1 over 2 x to the power minus 1 over 2. Good. And I think this is the same as 1 over 2 x to the power 1 over 2. And we can write this one as 1 over 2 square root of x. So that is gen prime of x. Now looking at the function, we need f prime, right? So let's also differentiate this. So we have f of x, which is equal to 1 divided by x squared plus 1. Is that right? Yes. So this one we can use the chain rule, or we can use quotient rule. So let's use quotient rule. U divided by vn. U is 1. U prime will be 0. Vn is equal to x squared plus 1. This implies that vn prime will be 2x. So f prime of x will be equal to vn u prime minus u vn prime divided by vn squared. So vn is x squared plus 1, u prime is 0, minus u is 1, and vn prime is 2x divided by x squared plus 1 all squared. So we're just doing substitution here. What are we going to get? This one will be 0. This will go to 0. So we are going to have minus 2x divided by x squared plus 1 all squared. So this is going to be f prime. So let's bring down the formula here. So we want to find something like this, right? So let me just copy this one and send it down there so that we can see what we are doing. Good. So let me paste it here. So first, we have gen prime, which is here, but we need f prime of gen of x, right? So since we have f prime of x to be equal to minus 2x divided by x squared plus 1 all squared, I can put all my x's into parentheses because this is a composite function. I don't want to make a mistake. So I can write this one as minus 2x all x in parentheses plus 1 all squared. So now that I need f prime of gen of x, it means that now this x here is now gen of x. So I'm going to have something like this. F prime of gen of x, which is equal to minus 2 times gen of x divided by gen of x squared plus 1 all squared. So what did I do here? I just replace all the x with gen of x. Good. Now what is gen of x? Gen of x is given as the square root of x. So now let us replace all the gen of x by square root of x. So square root of x, which is equal to minus 2 square root of x divided by square root of x squared plus 1 all squared. So this one will cancel this, and we are going to have minus 2 square root of x divided by x plus 1 all squared. So now that we have gen of x here, f prime of gen of x to be this, we just need to multiply it to gen prime. So it means that finally d over dx of f of gen of x will be equal to minus 2 square root of x divided by x plus 1 all squared times gen prime. So what do you get for gen prime? That is 1 divided by 2 square root of x. So this will cancel this, and finally minus 1 divided by x plus 1 all squared. Good. So that's what we are going to get. 1. Okay, so we have something like that here. So that's for question 10. We have 39 more questions to go. So now find the normal line to the curve. Good. So the word here is curve, not circle. So now this one is going to be this minus 1 over m x minus x1. So you see, we interchange the formula when we are dealing with curve. Good. So now we have the point here. So we are going to have y minus 2 is equal to x minus 4. So all we just need to do here is to find the slope, right? M, which we can get is from this. So y is equal to square root of x. Y is equal to x to the power 1 over 2. So let's find the slope. dy over dx is equal to 1 over 2 x to the power 1 over 2 minus 1, which is the same as slope. So 1 over 2 x to the power minus 1 over 2. So what is this? This is the same as 1 over 2 divided by 1 over 2 here when I bring it down. And this is the same as 1 over 2 square root of x. But x is given as 4. So I'm plugging in 4 and I'm going to have 1 over 2 square root of 4, 1 over 2 times 2, and this is 1 over 4. So now the slope is 1 over 4. So let's plug it in here. We are going to have this one to be y to be equal to minus 1 divided by 4, x minus 4. Then when I move the 2 to the other side, I'm going to have plus 2. So this is going to be y is equal to, this is 1 divided by 1 divided by 4. So this is the same as minus 4. Then x minus 4 plus 2. So guess what I can do here? Now this is y is equal to minus 4x plus 16 plus 2. So y is equal to minus 4x plus 18. Minus 4x plus 18, which is B right here. Wow. Now let's look at the next question, which is question 12. At a point where the graph of a function has a tangent line, where concavity changes is called the point of inflection or the inflection point. Good. Let's look at question 13. Should I leave you this to do? Yes, I'm going to leave this one for you to solve it, and then you leave your final answer in the comment section. So this one, differentiate this 4 times. When you are done, you plug in 1, and then you have gotten your solution right there. Now let's look at question 14. So we want to find the critical numbers from this function. So let's go through very quick. F of x is equal to x to the power 3 over 5, 4 minus x. So for me to differentiate here, I can use the product rule, or I can decide to multiply this one through and have 3 divided by 5 minus. Now don't forget, this is to the power 1. So when I multiply, I need to add the base. So I'm going to have x to the power 3 on 5 plus 1. And this is going to give me 3 on 5 minus, this is x to the power, this is 5 over 5. So this is going to be 8 divided by 5. So now I can differentiate this. F prime of x will be equal to 4 times 3 on 5 times x to the power 3 on 5 minus 1 minus 8 on 5 x to the power 8 over 5 minus 1. So this is going to give us 12 on 5, 12 on 5. This is going to give us 12 on 5. No, yeah, this is going to give us 12 on 5. And the top is going to give us minus 2 on 5 minus 8 on 5. And this is going to give us 3 on 5. So let's try and simplify this. So this is the same as 12 divided by 5x to the power 2 on 5 minus 8, 5, x 3 on 5. So we can try to simplify this. I can find some LCM here. So I can write, remember how we do our function, this times this, and then this times that. But the 5 is here, the 5 is here. So it's like I want to cancel the 5 out. So I'll just multiply this one by 1. Or let me say you are finding the LCM. So this is 5x to the power 2 on 3 divided by. So this one goes here 1, and this one will be 12 minus this one goes here, and to be left with this multiplying this. So I'm going to have 8x to the power 3 on 5 times x2 on 3. So this is 12 minus 8. The base are the same, so we need to add the top. And when I add, I'm going to have it to be, oops, I think this one's supposed to be 5. Yes. So this one is going to be just x divided by 5x squared divided by 5. Good. So when I add this one, I get 1, which is here. Now that I have a rational function, so we said, now this is f prime. You want the critical values, right? And we know that critical values are values that make the function undefined or makes the function equal to 0. So anytime we have rational function, we pick the top and we set it to 0. Just the top, set it to 0. So 8x is equal to 12, and x should be 12 divided by 8, which is the same as 3 on 2. I think so. 3 on 2. So that is the top. We are not done. We need to pick the denominator too and set it to 0. So this is the same as x to the power 5. X to the power 2 on 5 is equal to 0 when I divide through by 5. And when I want to find x here, x should be equal to 0. So the critical point is 0 and 3 on 2. 0 and 3 on 2. So we don't have 0 and 3 on 2 here. Okay, this one should have been maybe divided by 2, but we don't have the answer there. So that is question 14. Let's look at question 15. So question 15, we want to find the equation of the normal at, so the same idea. So I can leave this one for you to do it, right? So don't forget the equation of the normal here will be minus 1 over m x minus x1, right? So the point is given here. So just find m by differentiating this one. When you are done, plug in x and then just get the answer and leave your answer in the comment section. Let's look at 16. Okay, so 16, we want to find the derivative of f of x. So let's do that. This is tan x divided by 1 plus 2 sec x, right? So what we just want to do now is we want to differentiate. So this one, I think quotient rule will do for us, u and vn. So u is equal to tan x. U prime is, when I differentiate tan x, I get the secant squared x. Vn is equal to 1 plus 2 sec x. Vn prime, when I differentiate 1, I'll get 0. When I differentiate secant x, I'm going to have secant x tangent x. So what is f prime? F prime of x will be equal to vn u prime minus u vn prime divided by vn squared. So let's do substitution for this. Vn is 1 plus 2x, 1 plus 2 sec x, and then u prime is sec squared x minus u is the tangent x, and then prime is 2 secant x tangent x, all divided by 1 plus 2 secant x all squared. So let's try and simplify and see if we get some answers from the top. But let's look at the options first before. Okay, so options is not being simplified. So we have 1 plus 2 secant. Okay, so the answer is looking like C. Is that right? So we have 1 plus 2 secant squared, 1 plus 2 secant squared, minus tangent 2 secant tangent x, okay, divided by this. Good. So the answer here will be C. So they didn't simplify, so that's how we need to leave it. And let's look at 17. We want to find dy dx implicitly, right? So x y squared minus plus 6y plus x is equal to 0. So as usual, let's differentiate both sides. So y6 plus 6y plus x is equal to differentiating 0. So now I need to differentiate this, and I'm going to use the product rule. So first, product rule, I maintain x and differentiate y squared. So when I differentiate y squared, I'm going to have 2y times dy over the x, because this is y, plus, now I need to maintain y squared. So first I maintain x squared here, x, and differentiated y squared and get this. Now I need to maintain the y squared and differentiate x. So this is going to give us times 1 plus differentiate 6y, and I'm going to have 6. When I differentiate y, I get dy over the x, plus when I differentiate x, I get 1, and then differentiate 0 to get 0. So let's group like terms. This is going to be 2xy times dy over the x plus y squared plus 6y over this plus 1 is equal to 0. So let's just move some of the terms to the other side and see what we are going to get. So I'll move and have something like this: 2xy dy over the x plus 6 dy over the x to be equal to minus y squared. Here I can factor dy over the x out and left with 2xy plus 6, and this is minus 1y squared. So this is going to give us dy over the x to be equal to minus 1y squared 2xy plus 6. So let's see if we have the answer there. Okay, so I think it's supposed to be A. Yes. So we have the A here. Is that right? Yes, it's right. Let's look at question 18 and then the rest. So we have this function here, and want to check if they are true or false. So if this is less than or equal to this for x in this, then the critical value, this and this, so C is in this and this, there is it a local minimum at C. So what we just need to know here is, this one's supposed to be this. So this one's supposed to be greater than this. So if this one is greater than this, then this one becomes true. So this one is false. Now for it to be true, f of x here should be greater than or equal to f of this. Then this one becomes true. Now if this is less than 0, then we have concave down, true or false. So we said anytime we have minus and plus, minus is concave up and positive is concave down. So minus means that it is less than 0. And then less than 0 is not concave down, it's concave up. So this one too is false. It's less than 0. So concave up, not down. Good. Now, given the function f prime changes from positive to negative, the function has, so given a function, the function changes from positive to negative. So increasing, decreasing. This is concave down, which is maximum. So we are going to have this one to be A. We are going to have this one to be A. Now let's look at 21. Let's look at 21. For a function, f prime of x is positive, which is this, 7. F of x indicates, so assuming that we have, let's see, a function and f prime of 3 is 7. This means that this is greater than 0. So it means that basically the function is increasing like this at 3. So decreasing, no, because this is positive. Concave up. And then when it is positive 2, we have concave down, right? So pay attention to that. So this one is out, this one too is out. Okay, so now let's see which one are we going to choose here. So is it concave down at x or increasing at x? This is a lot of question to be taken here. So we cannot say that it is concave down. Why? Because for us to say that it is concave down, we need to make sure that it indeed changes on the other side. Because if we have something like this is here, let's say 4, or let me say, yeah, 5 is here, and we pick a point 3 here, and this is positive, it's increasing. And let's assume that we pick another point here and it's also increasing. We cannot say that this is concave down, right? Because for us to call it concave down and up, the sign should change. It should be changing to negative, right? So basically, we cannot say that this is concave down. So the right option here is increasing, because for increasing, as soon as it's positive, it means that it is going to increase, and this one too is going to increase. So here we don't know what will happen after we get to the other side, whether it's going to be going down or going up. So the best option here is C. Let's look at 21. 21, we want to find the point of inflection, right? So point of inflection is when we differentiate the function 2 times and then we set it to 0. But the function is already differentiated first time. So now gen prime is equal to x squared minus 2. So I can multiply through by x and have x cubed minus 2x. So gen prime will be equal to 3x squared minus 2. So let's set it to 0 and find for x. So 3x squared is equal to 2. X squared is equal to 2 on 3. And x is equal to plus or minus square root of 2 on 3. So this is the point of inflection. Now, point of inflection, always we need to put it on the curve to check whether it changes. But since the question is just asking for point of inflection, then indeed, it's definitely going to change, right? Good. That's basically how it's going to be. But if the question was asking, or we had a point which says there is no point of inflection, then it's good for you to put it on the number line, this on this one here, and plug them inside this one to check if indeed it changes from negative to positive before you can choose this one to be the point of inflection. Or even so that's right. Let's move to 23. Now we want to find y prime of this. So this one we are going to use the product rule. Y is equal to 4x squared plus 2x e to the power cos x squared 5x. So product rule, let's do that. Y prime will be equal to, so I'll maintain this, or let me choose A and B so that I'll be good with this one. X squared plus 2x, and then what will be A prime? So let's figure out A prime. A prime, this is the natural log, so I'm going to have 1 divided by 4x squared plus 2x times, then I differentiate what's inside the parentheses, which is going to give us 8x plus 2. So this is going to give me 8x plus 2 divided by 4x squared plus 2x. So this is A prime. Let's look at B. Let's choose B to be cos squared 5x. So B prime is differentiate what is on the top here and multiply it by this, or maintain this and differentiate what is on the top. So let's try and put this one here and differentiate it. This is the same as cos 5x all squared. So this one we need to apply the chain rule. So this is going to be power rule first, 5x, then 2 minus 1. Then I differentiate what is inside. When I differentiate cos, I'm going to have minus sine 5x. Then I need to differentiate what is inside again, and this is going to give us 5. So this is going to give us minus 10 cos 5x sine 5x for just differentiating what is on the top here, because this was going to give us 1, then this and this and this and that minus here. So this is what we are going to get. So here b is going to give us, when I multiply it by this, I'm going to have, so let me just move this one to the far end here so that I can write minus 10 cos 5x sine 5x. So that's what I'm going to get for b prime. So let's look at the product rule. So the product rule says that y prime is equal to first the second plus second the first. So this is going to be a is equal to the natural log of 4x squared plus 2x times b prime. So times the whole of this. So this is going to be times minus 10 cos 5x sine 5x e to the power cos squared 5x plus b is e to the power cos squared 5x times a prime, which is 8x plus 2 divided by 4x squared plus 2x. So let's check the final answer before we simplify. Okay, so this term came first. So this term came first. So let's see how we can simplify it. Okay, so let me just try and see how we can write this one again to suit the solution. So this term came first. So this is y prime, which is equal to 8x plus 2 divided by 4x squared plus 2x e to the power cos squared 5x. So let's look at the option. We have this one here. We have it also here. We have here. Okay, so the first part is the same thing throughout. So it's the second part that we need to look at. So the second part, we have minus 10 here. So we are going to have minus 10 natural log of 4x squared plus 2x times, let me see. Good. So times cos 5x sine 5x e to the power cos squared 5x. So the term that we need to look here is minus 10. So minus 10 minus 10. So it means that this option is out, this option is out. Here we don't have sine inside. So this one too is out. So this is out, this is out. But this is indeed the solution because we have the cos, we have the sine, we have this, and we have that. So this is going to give us A here. Good. Now let's look at the next question, which is question 24. So question 24 here, we want to find the critical values, right? So let's try and then figure them out. Let's try and figure them out. Let's try and figure them out. So now y is equal to x squared minus 6x plus 2. This one can be written as x squared minus 6x x to the power 1 over 3 plus 2. And this is the same as y x squared minus. Now this is to the power 1, so I'm going to add the exponent and have 6, 4 on 3 plus 2. So since we want to find the critical value, we need to differentiate this. So dy over dx will be equal to 2x minus 6 times 4 on 3 x to the power 4 on 3 minus 1. I differentiate this and this one gets to 0. So 2x, and then this is going to be minus 8x to the power, this is 1 over 3. So this is what I'm going to get. Let's try and set this one to 0, right? So 2x minus 8x 1 over 3 is equal to 0. Here I can factor x out and have 2 minus 8. So when I factor x out, this is to the power 1, so I need to subtract 1. And this is going to give us x to the power minus 2 on 3, which is equal to 0. So the first one is, I pick this one, set it to 0. So x is equal to 0. That's one point of the critical value. Then I need to pick 2 minus 8, x to the power minus 2 on 3 to be 0. So I can write this one as 2 minus 8. this is minus, divided by x to the power this on this is equal to 0. Find the LCM. This is by 1. So I'm going to have 2x 2 or what can I do here? Okay, so instead of find the LCM, we will go back to the question again. So what I can do here is, since this one is minus, I can write this one as, okay, so the same thing. I can write this one as this, and instead of finding the LCM, I'll write it as 8 x to the power 3 on 2, which is equal to 2, right? So I move this one to the other side. Then I'll multiply through, so I'm going to have 2x cubed divided by 2, divided by 2, and I'm going to have 4 is equal to x to the power 3 on 2, something like this. And then now, what I'm going to do is, for me to do this, I'm going to multiply this one as x to the power 3 on 2 times 2 on 3, and multiply this one to 2 on 3, so that this will cancel that. So x will be equal to, this is the same as x squared all to the power 1 on 3. So x squared is, I think, did I do this one right? Okay, this one's supposed to be 3 on 2, 2 on 3. This one to 2 on 3, sorry. So this one will be 2 on 2. So yeah, 2 on 3. So this is rather 2 on 3, 2 on 3. So this one rather will be 3 on 2, which is equal to x 3 on 2 times 2 on 3. What am I doing? Yeah, so this one will be 2 on 3. No, good. So for me to cancel, I need to do this one. What am I doing? X is 2 on 3, right? Okay, this one should be 2 on 3. So I'll multiply this one by 3 on 2, so that this will cancel this will cancel this. So this one too should be 3 on 2. So this is going to be 3, and this is going to be squared. So, sorry, 1 over 3, 1 over 2. So 4 to the power 3 is, I think, 64. And square root of 64 is going to give us 8. So this is going to give us plus or minus 8. So the critical values is going to be x is equal to 0, minus 8, and 8. So we had 0 here. One of them is here, and this one is giving us plus or minus 8. So that will be the critical values, which is going to give us a here. Now, local minimum is, so now we want to look at local minimum and then local maximum. So we know how to do that, right? So for local minimum and maximum, we need to put this one on normal line. So we have our 0 here, we have our minus 8 here, and we have 8 here. Don't forget, for local, we need to use f prime of x. So what was f prime of x, or dy over the x? So this was dy over the x. Let me just send it down there. So let me make dy over the x as f of x, which is equal to this. So what we are going to do here is, we are going to just pick a point here, point here, point here, point here, and plug it inside this and see what we are going to get. Plug in minus 9 and let's see what we are going to get. Let's plug in minus 9. So minus 9 inside this is going to give us 2 times 9 is going to be 18, minus, now 9 to the power 3 is going to give us 9 to the power 1/3. Well, let me say cubic root of that. It's going to give us some point. So times 8 is going to give us something like 16. So this is going to be positive. Okay, so let me just, this is going to be positive. This is going to be positive. Plug in something like, no, this is not going to give us negative, positive, because this is going to be, okay, let me just do it again. 2 times this one is going to give us minus 18 minus, this is cubic, so it's always going to bring us the negative. So this is going to be plus. So this is going to be 8 times cubic root of minus 9, which is going to be 16. Okay, so it's still going to be, so, okay, so this is going to be minus. Okay. Let's plug in something like minus 7 will be here. So minus 7 times this one will be minus 14 plus then 8 times cubic root of 8 times cubic root of minus 7, which is going to be 15. So this will be plus. Let's plug in something like 7 there. So 7 there is going to be 14. And when I plug in 7, I'm going to get it to be negative. And this is going to be minus, because this is going to be minus 15 something. Then plug in 9. 9, this is going to be 18. When I plug in 9 there, I'm going to have 8 times cubic root of 9, which is going to be 16. So this is also going to be positive. Okay, so now let's check where we can see up and down. So this is up. No, this is supposed to be down, up, down, and up. So concave down is going to happen here. Concave down is going to happen here at 0. So we are going to have x is equal to 0 to be local minimum. No, local maximum, sorry. Local maximum. And then minus 8 and positive 8 is going to be the local minimum. So x is equal to minus 8 and 8 is both local minimum. But the question is asking us to find a point, right? So we need to plug them inside the original function, right? So when I plug in 0, 0, I'm going to have 2. So for the local maximum, I'm going to have 0 and 2 for local maximum. So let's look at local maximum. Local maximum 0 and 2 is here for local maximum 0 and 2. For local maximum, for local maximum is 0 and 2 here. Now for local minimum, I need to plug in this point inside the original function. So minus 8 and 8 inside the original function. So let me try and plug in 8 here. So 8 inside this is going to give us 64. A squared is 64. And then let me try and fix 8 here. So 8, 6 times, or let me say, cubic root of 8. Cubic root of 8 is 2. And then 2 to the power 4. 2 to the power 4 is going to give us 16. 16 times 6 is going to give us 96. So this is going to be minus 96, then plus 2. So let's add it. Minus 2 minus 64 from 90. This one is going to give us minus 30. So for positive 8, we are going to have 8 and minus 30. Then for minus 8, when I do it, this one become positive because this is cubic. Okay. Oh, no, still become positive. So it's still, because of the 4 here, it still become positive. So the same thing for this one too as well. So minus this. So which one was given. So we had both of them here. Okay, so this is not minus, so it means that we are choosing this, because this is 8 and minus 30. This is minus 8 and minus 30, but this one is not that. Yeah, so we are choosing this one as D. So for local minimum and local maximum. All right, let's look at question 27. We are almost there. So look, question 20, we want to find the slope of the circle, right? So this one, we just need to use the implicit differentiation here, which is equal to 25. Differentiate x squared and have 2x plus y squared 2y times dy over dx, and it will be equal to 0. Plug in the point. X is minus 3, so minus 3 times 2 is going to give us minus 6, plus y is 4, plug in 4, and we are going to have 8 dy over dx, and then 8 dy over dx is equal to 6. Dy over dx is equal to 6 divided by 8, and this is 3 divided by 4. 3 divided by 4, 3 divided by 4 is here. Now let's look at this one. So also do this one. You need to try this one. You will find the slope, the same thing like what we did up there. Then find the equation of the tangent to the line. Okay, let me just basically do this. So dy over the x is equal to, so we want to differentiate this, use the power rule. We are going to have 18x plus 7 times 4 is 28, x to the power 3. Right, so plug in 1, 8 times 1 plus 28 times 1, and then 28 plus 18 is going to give us 46. So that will be the slope. Equation of the tangent, this is to the curve, so y is equal to y minus y1 is equal to m x minus x1. So looking at the equation, this here is the same as this, so we are going to use the slope, which is 46, and we use the point 1 1 to fix them in. So this is y minus 1 is equal to 46 x minus 1. Let's look at how they arrange the function. So y is equal to 46 minus 46 plus 1, and this is going to be y is equal to 46x minus 45. 46x minus 45. Okay, indeed, we have it here. Let's look at 30. We are almost there. We have 49 questions. We are almost there. Here we want to differentiate this one and set x to be equal to 1. So f of x is equal to 2x squared ex. Product rule. Product rule. I can set a to be 2x squared and b to be ex. B prime is the same thing because this is an exponential function. A prime will be 4x. So let's go. This is a b prime plus b prime a. So this is going to give us 2x squared ex plus ex. Is that right? This is a times b prime. A times b prime. Okay, and then this one is a times b prime. So this one's supposed to be a prime. Good. So I was just confused. Good. So this one is going to give us 2x squared ex plus 4x ex. Okay, at x is equal to 1. So when x is 1, 1 squared e1 plus 4 1 e1. So this is e2 plus or 2e and 4e, and this is going to give us 5e. We don't have 5e. It's supposed to be 6e rather. Okay. Okay, so that's 30 for us. Given f of x, which is equal to 4 over 3 log of x to the power 3, this is finding f prime. So we know how to differentiate the log function. So let me just put this one inside parentheses. You see that the answer given to us here, we don't have anything by like in the name of log. We know that this is supposed to be base 10. But since we don't have anything like length, natural log of 10, it means that we are assuming that this is e, the base is e. So this is going to be 4 divided by 3 times 1 divided by the 1 divided by what is inside the parenthesis times length of the base, which is e, times I differentiate what is inside the parenthesis and have 3x squared. So now this will be 1. So I'm going to have 3 will cancel 3. This will cancel this one and be left with x. So I'm going to have 4 divided by x, which is a. So this one, we chose e because we don't have anything with length base 10 here. Good, so that's the idea. But if we saw something like length base 10, then we should have changed this one to 10 so that this one will be length base 10 and have this. 32. Find the derivative of this. So let me leave this one for you. Try and find f prime of this using the product rule and leave your answer in the comment section. Let's look at 33. So for 33, we want to find the function is in this interval. So we want to check if the function is always increasing or sometimes it's going to decrease. So let's try and find out. So with this one, what we just need to do is we need to differentiate the function first. So when I differentiate it, I'm going to have 4. And 4 is positive. So you see that the function is going to be increasing always between this interval here. It's going to be increasing because this is a constant, and no matter the value of x that we are going to choose between this, is going to still be always 4. So this one is going to be always increasing. Now we want to differentiate this. So let me assume that y is equal to the natural log of x squared minus 4. Natural log of x4 minus 4. So as you can see here, the answer given to us has no length of 10. So we are going to assume that this is e. So dy over dx will be equal to 1 divided by what is inside the parenthesis times length of the base, which is e, times we differentiate what is inside the parenthesis and we're going to have 2x. So dy over dx will be equal to 1 divided by x squared minus 4 times 2x. So this is dy is equal to 2x over x squared minus 4 dx. So that's what we are going to get. Let me see. Is that a? Is that a 2x, or the denominator is minus 4, so that's supposed to be this one here. Good. So that would be b. At 35. So for 35, we know that when we differentiate cosecant, what are we going to get? When you differentiate cosecant, what are you going to get? So we are going to have what? That's basically we are going to have b, right? So it's just knowing how to differentiate cosecant of x, and then you are there. Now when you differentiate cotangent, what do we get? We get minus cosecant squared, but it's minus, so minus will be positive, so it means that we are going to choose this one. Now we want to find dy over dx of this, so let's do that. I think we've done something like this. Yes, we've done something like this in the solution, and we had this. I remember this one here. Yeah. So I think we've done something like this. Y, oh no, this one is different. I think this one, the one that we did was x y squared plus 6. Yeah. So let's just do it again. So this is y x squared plus 6y plus x is equal to 0. Let's differentiate straight. Use product rule, maintain y and differentiate x, plus now maintain x and differentiate y. 6 dy over dx is plus 1 is equal to 0. So this one, there's more change in this one. So this is going to give us 2xy plus x squared dy over dx plus 6 dy over dx, which is equal to 1. So I'll move this one to the left, x squared dy over dx plus 6y here on the left. Then move minus 1 minus 2xy. Factor dy over dx out and have x squared plus 6, which is equal to, I can factor minus out, plus 2xy. So dy over dx is equal to minus 1 plus 2xy divided by x squared plus 6. So you see, when I saw this question, I was thinking I've solved it before. So I was just going to choose the results. And indeed, it was totally wrong. So that's one thing that you need to know. Anytime you go there, you see that, oh, I've solved this question before. It's good for you to verify. So is it I was choosing A, but the answer is not even A. The answer is C here. So basically, that is the idea. Always, since you know how to solve them before you choose the answer. Unless maybe time is up and you are rushing into, finish it up. Now, dy over dx is equal to, so 1 divided by what is inside the parentheses times differentiate what is inside the parentheses, which is going to give us minus sine x divided by cos s. We don't have it there, but we know that sine is the same as, sine over cos is the same as tangent. So we are going to have this. Let's do this one. Y is equal to x cos x. So this is non-constant base. So we need to pick the natural log on both sides. Then we use one law of logarithm to make sure that cos of x comes down. Then we can use the product rule to, do this. So this is equal to, y prime divided by y is equal to, or let me just write it, this one in parentheses. So 1 divided by y times y prime. This is, if I maintain this and differentiate this, I'm going to have cos s times 1 over x plus, now I maintain ln x and differentiate cos, and I have minus sine x. So this is 1, or let me see, y prime. This is 1 over x cos x minus ln x sine x. Then since we need y prime, we have 1 over x cos x minus ln x sine x, all times y. Y is equal to, okay, they didn't simplify. Y is equal to, we're supposed to place it there, but we don't have it there. So we have 1 over x cos s. So this is cos, this is cos. So b and d is out, and this is minus, and it's here. So we are going to have this one to be c. We are going to have this one to be c. Now let's look at these questions here. Let's look at these questions here, right? So what is the question? So if this is a local maximum of f of x, then this is less than this at the interval here. This is true. If this is a local maximum, then this is greater, this is in between this, and okay, so this one too is also true. A function f is said to be increasing if f prime is greater than 0 on a and b. This is true. This is greater than 0, then we have concave down. So let me see. We have f prime prime to be positive. So positive is concave down and negative is concave up. Because when it is this greater than 0, this one is going to give us minimum. Is it minimum? Yes, when this one is greater than 0, it's going to give us minimum. Okay, so this one is going to be false. because when we put this one inside and it is greater than 0, this is minimum. So minimum should be something like this. And then when this one is less than this is going to give us maximum. F prime prime, this one is going to give us maximum. So maximum is like this. No, maximum is like this. Good, so this one is true. This one is true. Yeah. All right, let's look at 45. We're almost done. We have like some few questions to go. Okay, so let's find y prime here. Ex sine ln of 2x plus ex cos s. So y prime, the first one is product rule, right? So I maintain ex and differentiate this. This is going to give us cos ln of 2x times, this is change rule. So I differentiate sine, I had cos. I need to differentiate what is inside the parentheses. So I'm going to have 1 divided by 2x times 2. That's the ln function, which is ln of 2x. Plus, now I need to maintain sine ln of 2x and differentiate ex and get the same thing. Then now plus this is plus e to the power cos s. Then I differentiate what is on the top and have minus sine x. So let's see. Let's try and write it in the form of what is given. So they wrote this one first. So we are going to have sine ln of 2x. This one is supposed to be x here. Ex. Then this one is going to give us minus. So let's see how they wrote this one. Is it minus or plus? Okay, so it's plus. This and this will cancel out. So I'm going to have 2. I'm going to have 2. I'm going to have 2. Oh no, 2 will just be going out because there's no 2 here. This one will cancel. So I'm going to have ex cos of ln 2x and then minus sine x cos of x. So let me see how they did it. So we have this, this, and that, which is here. Then they have e over x. Oh, okay. This one's supposed to be divided by x with this one here. So we have e over x throughout. We don't have some here, so this is out. Then we have cos of ln 2x, which is also here. Then we have the minus this, which is here. Okay, so I think the answer is supposed to be C. The answer is supposed to be C. Now let's look at the last 4 questions, then we are done. A farmer has this to fence of a fencing material and want to fence off a rectangular field bounded a straight river. So let's assume that this is the river here. So we are going to have something like that. So if we have something like this, I can name this one to be x. It means that this one is going to be x and this one is going to be y. So for us to fence this one, which we have this, then we are going to have the parameter, which is going to be this plus this plus this, supposed to be equal to this. So we are going to have the parameter to be equal to x plus y. And this is going to give us 2x plus y. But the parameter is given, which is equal to this, 2400. So this is going to be 2x plus y, which is equal to 2400 or 2400. So this is going to be false because we're supposed to have 2x there. What is the area of the field? What is the area of the field? So for us to find the area, we know that area of a rectangle is going to be xy, like this. But here we can make y the subject and have something like y is equal to 2400 minus 2x. So we can put it in here and have x times this minus 2x here. So that's basically what we can do here. And let's multiply it through and see x minus 2x squared. So let's see if we have something like that there. Yes. So something like this is here. Good. Now the question is asking us to find the shortest length. So it means that we need to find for x and y and see which one is the shortest, right? So let's do that. Let's do that. So we are going to have a to be this. So we need to find them. We need to maximize or minimize it, right? Or we need to minimize it. So a prime will be equal to this minus 4x. When I differentiate it, I will set it to 0. So this minus 4x is equal to 0. So what am I going to get here? What am I going to get here? This is going to be 4x is equal to 2400. And what am I going to get from this? Divide through by 4. So 4 goes to 24, I think 6. So this will be 600. So x is 600. Let's look for y. So this one will be y is equal to 2400 minus 600. And this is going to give us 1800. Good. So y is 1800 and x is 600. So the shortest one will be x, which is equal to this. Let's do the last question. I hope so. Yeah, so this is the last question. And then we are done on this one. So air is being pumped into a spherical balloon so that its volume increases. So this one we are talking about increase. So this one here we are dealing with the volume, right? So the volume is going to be with radius. So here we are going to say something like, since it's going with volume and it's going to increase, so this is going to be the change. So the V divided by the R is equal to, this is going to be positive, so 100, because we are talking about, this one's supposed to be going with time. So we are going to have this one to be 100. Now, how fast is the radius of the balloon increasing when the diameter is 50? So we know that diameter is equal to 2r. So for us to find radius, 50 is equal to 2r and r will be equal to 25. Good. Now, what is the formula for finding volume of a sphere? Volume of a sphere is 4/3 pi r cubed. So now we need to differentiate this with respect to time. So let's do that. The V over the t is equal to 4/3 pi. Then we differentiate r with respect to t. So this is going to be 3r squared times dr over the t. So what we are looking for is, we are looking for how fast the radius. So we are looking for dr over the t. We are looking for this guy here. So now this will cancel this. So I'm going to have 4 pi r squared dr over the t. Then v over the t. So if I want to find the r over the t, this is going to be 1 divided by 4 pi r squared times v over the t. I know r to be 25. I know v over the t to be 100. So I can do substitution here. So 1 over 4 pi, then 25 squared times 100. So that's basically what I'm going to get here. Now 4 will cancel 125, and then 1 of the 25 will cancel 1 of the 25 here. So I'm going to have this one to be 1 divided by 25 pi. So let's see, 1 over 25 pi, and we are going to have C. All right, so this is the end of the video. The one that I told you guys to do, please do it and leave your solution in the comment section. And don't forget, we have our last video so that we can write the exams with confidence. So the last video which is be coming up is integration. So we are going to take some questions on integration too as well, and then see you